Okay, now we're going to do expansion manually, and we're going to look at these rules here. So in general, when you want to expand, you've got two brackets. There's the first one, there's the second one. We use FOIL. Now the FOIL is the two firsts multiplied by each other plus the two outers multiplied by each other plus the two inners multiplied by each other plus the two last multiplied by each other. Now the firsts are the two first numerals or pronumerals in the bracket. So doing A times C will give you the two firsts. Now you follow it up with the outers, and the outers are the two outside numerals or pronumerals in each of those brackets. These are the two outers. So when you multiply them together, you get the next one, AD. That's the outer in that word. The next one is the inners, and the inners are the two inside numerals or pronumerals. So those two there multiplied by each other will give BC. We call that the inner. And then of course we finish off with the last, and that is the B and the D. So that last and that last, multiply those two together and we get BD, and that's the last. So that's the complete FOIL expansion. That works in all cases. There are special cases where you can have a shortcut to that method, and that's when you see that there is the two brackets, there is symmetry about it. So the two firsts are the same, the two last are the same, but you've got alternating signs. And you find the outers and inners will actually cancel, and you just end up with the first squared minus the last squared. The other special case is the perfect square rule, and that's when you've got a repeated bracket, repeated factor. So it's A plus B all squared. What happens is you get the first squared, you also have the last squared, but the outers and inners are double the product of the two numerals or pronumerals. And if it's minus, you've got minus double the product of the numerals or pronumerals. Alright, so that's the summary of the rules that we'll be using. We're just now going to do lots of exercises. I'll do a few and then you can try some for practice. So the first one is these ones here, 1b, 2x plus 3x plus 1. Now if we multiply the firsts, we'll get 2x squared. And if you do the outers, now I want the outers and inners to be done together in the head. So 2x times 1 is 2x, 3 times x is 3x. So 2x plus 3x is 5x. That's the outers and inners done in one hit. And then you follow up with the last, which is 3 times 1, which is 3. So that's the answer there. We write them in that order, highest power, then go down in power. So x squared, the x term, and then the number, the constant term. I'll grab another one, like let's go down to, say, this one here, I. Doing the first, we get 21, and doing the outers and inners together, we get minus 14x minus 3x. So that's equal to minus 17x. And doing the lasts, we get plus 2x squared. Now what we do is we rearrange that to make the highest power first, followed by the x term, followed by the constant term. Alright, so you can have a go at those and check the answers at the back. Here are the, just pause the video and come back. And here are the answers to 1b, question 1, A through to L. Back to 1b, question 2. This is now using the difference of two squares rule. You can actually use the FOIL or you can use this shortcut method. So as an example, I'll do, say, D here. And we've got 3x take 2, 3x plus 2. They're symmetrical, the same first, same last, but alternating signs. So if we apply this rule here, we just have to square the firsts and get 9x squared, square the lasts, so that get 2 squared, which is 4, and it's minus. It's if you did the outers and inners, you can see you get plus 6x take 6x, and they give 0. That's why you don't have to have outers and inners done with the difference of squares rule. So you can try them, pause them, and check your answers. And here's the answers to question 2, all the difference of two squares from A to L. The next rule is the perfect square rule, and that's where you have a repeating factor or a squared factor. So for example, let's do this one here, I. What we want to do is use the expansion, the perfect rule expansion, which is, I haven't got it written there, I'll just write it again. So it's a plus b squared is equal to the first squared plus double the product of the two numerals or pronumerals plus the last squared. Now using that concept, we can square the first and get 4x squared. And we're going to double the product of that being 14x, double that we get 28x, and you finish off with the square of the last, which is 49. Now you could have done using FOIL, but this is slightly quicker, where you just have to double the product to get the outers and inners. Alright, you can try those set of questions. And here are the answers to 3, A through to L. Okay, so there's enough, there's heaps of questions there, so we don't need to, this should be Year 10 revision. We're going to now go backwards the other way, called factorisation. Now factorisation, you can follow a step process like they've got here. What you do is you ask the question first, can you take out any common factors? That'll make life a lot easier if you can. Then the next question you ask is, can you identify any quick ways of doing it? Is there a difference of two squares? Is there a perfect square? Or do we have to use the standard FOIL because it's in general format? I'll write the rules up on the right hand side so that we can refer to the particular rules, and the rules are either foiling, that's in general, we can always use that. The special case of foiling is the difference of two squares, and that's when you have a squared take b squared. We can make that a plus b, a take b. The other special case was the perfect square rule, which is a squared plus 2ab plus b squared, and that can be factorised into a plus b all squared. Of course, we could have that as a minus. If it was a minus there, then we would have a minus there. Alright, so I'll place that up the top so that we can refer to one of those three types. Okay, so looking at the first set of questions, we have 3x squared plus 9x. The first thing you ask is, can you take out a common factor? And we can take out 3x. and you're left with x plus 9, sorry, x plus 3. Now if you expand that, 3x times x you get 3x squared, 3x times 3 you get 9x. Okay, so we're dividing by 3x, or taking it out of those two terms, and that's in factorised form. Now the reason factorisation is very useful in mathematics is that we can have an idea of what the graph looks like from factorised form, because if that's one factor, that means if x is minus 3, we'll get 0. So that's a 0 or a root or x-intercept for the graph of that quadratic. The other thing I make it 0 is when x is 0, that's that point there. So the graph actually looks like that. So factorised form gives us a quick idea of x-intercepts, whereas we wouldn't have got that quickly by looking at the general form from there. Okay, next one, 2x squared plus 7x. Can we take out a common factor? Yes, x, and left with 2x plus 7. If we look at another one, 4x squared take 10x, we could do the same thing, we take our x out of there. The next different type of question we see would be this one here, and you have to spot that as a difference of two squares. So that's that second rule, this one sitting here, a squared take b squared, and that'll be a plus b, a take b. So here we want to put it as a difference of two squares. 9x squared is really 3x all squared. Now the 25 is 5 squared. That's a difference of two squares, so using that second rule there, we can say that that is equal to 3x take 5 and 3x plus 5. And you can do that whenever you've got differences of two squares. So the other places that we see that on here is this one here, that's 1 squared, and that's 4x all squared. This one here, that's that's root 2. If you wanted to actually express that as a square, it's root 2x all squared minus root 8 squared. That can be expressed as a difference of two squares. Alright, so there are quite a few of those there. There's that one, there's that one. Now we're getting into ones that aren't difference of two squares, but these are in general form. So the general form, we just use the FOIL. And to do FOIL backwards, we just have to trial and error, try and get into two brackets. So there's your two brackets there. What will give the firsts, being x squared, that'll come from x and x. What will give the last, it'll be 4 and 4, 4 times 4 is 16. And what will give outers and inners being 8x, well, you'd have to have a minus and a minus. So you have outers being minus 4x, inners minus 4x, so outers and inners together is minus 8x. And confirm that when you do the last, the minus and minus is a plus, so plus 16. Okay, so that's sort of like trial and error to do that FOIL backwards. So if you don't have one of these two special cases, you have to use that foiling method. Okay, so you could do the same with k. When you get a little bit harder, when you've got, say, a 2 out the front, like that one, probably to make that simpler, you've got to, if you can spot the common factor, see there's 2, that's 8 and that's 8. So a better way to do that one would be to take out the common factor first, and you're left with x squared take 4x plus 4, and then you factorise this bracket. So that goes into the two separate brackets. X times x is x squared, the 2 times the 2 gives the 4, and to get the minus 4 outers and inners, you have to have a minus and a minus. But it makes it a lot easier if you take out that common factor first. You can actually use that concept even when you do the difference of two squares. You could take out the common factor of 4 and be left with x squared take 5, and then because that's a difference of two squares, you can then say it's 4x take root 5 x plus root 5, because root 5 times root 5 is 5. Okay, you try all of one and then come back. And here are the solutions to 1C1, A through to O. Now we can jump to some harder ones. Let's go to question 3, where you've got a number outside of x squared. So we'll do 3 part A. I might need a bit of room to do this now, so I'll reduce this. Okay, so putting the question down, we have 3 part A, 2x squared plus 5x take 12. Okay, using FOIL backwards with that one, we need to put it into, we can't take out any common factor, but we have to jump straight into the FOIL backwards. Now to get 2x squared, that's got to come from 2x times x. That's the 2 first. Now the last could come from 4 times 3 or 3 times 4, because that actually will be different answer, because these gets multiplied by the outers and inners, and the first are not the same, so you're going to get different answers. So you have to put them in the different order. You could also have 6 and 2 and 2 and 6. Now what we have to do is try and work out which is going to be the best option, or the only option. So if we take the top one, when we do the outers and inners, we're going to get 6x and 4x. Now 6x and 4x will never end up being 5x, whether you're adding or subtracting, so we can't use that option. If you take the next option, 4 and 3, the inners is 3x, the outers is 8x. Now the difference between 8x and 3x is 5x, so that looks like a good option. We'll just knock off the others just to make sure. 6 and 2, the outers would be 4x and inners would be 6x. That won't work. Or the last would be 6, the outers is 6 times 2, which is 12x, and the inners 2x. 12x and 2x won't give 5x. So clearly the 3 and the 4 are the best option. So we'll just tidy that up now and then work out the signs. We can get rid of these ones that don't work. And now we have to work out the signs. Now to get plus 5x, that has to come from the biggest, which is this one, the 8x. So we've got to have plus there, so we have plus 8x, and the minus there, so plus 8x, take 3x will give us our 5x. And just confirming 4 3s are 12, minus and a plus is a minus. So it's trial and error. You just do it from the question and you go straight into the answer. Doing another one, say 3x squared take 5x take 2. 3x squared take 5x take 2. We can't take out any common factor, so we have to go straight into foiling backwards. 3x squared comes from 3x times x. The 2 can come from 1 times 2 or 2 times 1. If we do the top option, the outers will be 6x, the inners will be 1x. Difference between that will give 5x. Or if we take the bottom, it'll be 3x and 2x, which also give 5x. But because we have to end up with minus 2 as the last, we have to have alternating signs. So it couldn't be that bottom option, because we've got to do plus 3x plus 2x, the same sign. So we're going to go with the top option and alternate the signs. To get minus 5x, we have to have the minus with the biggest, which is the 6x, and then plus the smallest, the 1x. So minus 6x plus 1x is minus 5x. And confirm the last, 1 times 2 is 2, plus and a minus is a minus. Okay, so a bit of trial and error, a bit of thinking, but the more you do, the better you get at these. Okay, so I'd try all of 3 and then come back. And here are the answers to all of 3, 3a through to u.